All right, it's time. Let's get started. So good morning, guys. Today we're just gonna do some proofs and sets problems. So let's start with the first one. Just do like an induction problem. I will give you guys about 3 minutes to work on this one. All right, so let's start with the problem statement. Or should I then just let the P of n to be n factorial is greater than 2 to the n for n is greater than or equal to 4. And what's the base case you want to start with?
Four.
Yeah, 4. Since we have like n is greater or equal to 4. So if we just look at it like left-hand side, which is 4 factorial, and that should equal to 24. And if we then check 2 to the 4, that should give us 16. All right, and then we have proved the base case. So what's going to be our hypothesis?
P of n is true.
Yeah, we can assume the Pn is true. We should have n factorial is greater than 2 to the n. And then for the steps, we can just prove the next term, which is P of n plus 1. So we can start from the n plus 1 factorials. And then how would we show that is greater than 2 to the n plus 1?
We can factor the factorial to n factorial times n plus 1.
Exactly. And what's the next step?
At this point, I think we should use the induction hypothesis and plug in the 2 to the n. So n plus 1 times 2 to the n is going to be less than n factorial times n plus 1.
Yep. So we just use the hypothesis. And we get this. And how do we get the is greater than 2 to the n plus 1? So think about like the choices for n. N has to be greater or equal to 4. What does that imply about n plus 1?
That it's greater than 2. So we can get
exactly.
another
So we know.
inequality.
Yep. So we know that n is greater than or equal to 4, and thus n plus 1 has to be greater than 2. So we can just rewrite this as greater than 2 to the n times 2, and that's just 2 to the n plus 1. And you're done with the proof. All right, any question on this problem? Great. Okay. So the next one gonna be a pigeonhole problem. So we have standard 6-sided die, and it's asking what's the fewest number of times you must roll before you are sure that at least 10 of the rolls resulted in the same number. So just try to find out the m and n, and then m times n plus 1 in this case. What's going to be that number? I will give you guys about 2 or 3 minutes. All right, so anybody wants to share what they got for the fewest number of times you must roll?
55.
Do you want to explain how you get that?
Yeah. So I used n equals 6 because we're using a 6-sided die. So using 6 pigeonholes and then we want m plus 1 equals 10. So therefore m equals 9, and then plugging it in, 9 times 6 plus 1 is equal to 55.
All right, great. That's exactly what you need to do. So right here we have 6 boxes or 6 containers in this case, where you can think about every time you roll a 1, you can just put an object in box 1. And every time you roll 2, just put another object in box 2, like etc. And then the at least 10 of the rows resulted in the same numbers. That basically means that at least 10 objects in the same box. So where we have the m plus 1 equals 10. And then you just substitute that into this m times n plus 1 equation, which will give you the total number of times you must roll. Any questions on this one?
Yeah, so since it's asking for the fewest number of times, don't we need to also show explicitly that anything less than 55 rolls wouldn't result in the correct overflow, and anything more than 55 rolls would result in a greater overflow than 10?
So the equation right here actually assures that it's the fewest number of times you must roll. Because you have the m plus 1 equals 10, that's actually at the least number in one box. All right. Any other questions?
Sorry, that makes sense. Thank you.
Cool. All right, so the next one going to be elements of set problems. Suppose we have this ABC 3 sets and list 5 elements in the following set where A intersects B union C. I will give you guys 2 or 3 minutes to work on this one. It will be helpful if you just write the first 5 or 6, 7 terms of the 3 sets. And then just find the union and then the intersection of those. All right, so why don't we start from writing out the elements in set A. So the element x in set A belongs to natural numbers. We start from 0. And then x equals to 4k for some k belongs to natural numbers. So anyone who wants to give a shot about the first 5 or 6 elements in A?
Would just be multiples of 4, so 0, 4, 8, 12, 16, 20.
Exactly. And then you just keep going on. And what about the elements y in B? Remember that 2y is a perfect square, but not y. So why don't we start right out like what are all the 2y's? So we know that 2y is a perfect square. And if we just first write out like what are all the perfect squares?
Would it just be all of the perfect squares that are even?
Yeah, exactly. So yeah, so and there are 4, 16, and what else? And 18. Wait, no, sorry. That should be 36. And then 64, and then 100, and 144. So, and those are the 2y. And in terms of y, that's just going to be 2, 8, and 18, and 32, and 50, and 72. All right. And what about C? So remember that C belongs to all the integers, which means they include all the negative numbers as well. So for C, it's actually just all the numbers from -31, -32, and all the way up to 30 and 31. All right. So let's just list 5 elements in the A intersects B union C. And what are they?
Would it be 0, 4, 8, 12, 16, 28, 29, 36.
Yeah. And 5 elements is enough. All right. Any question on this part?
Can you remind me what the forms of perfect squares are? Was it 4 times an integer plus one? I can't remember how that goes.
A perfect square, just like integer times itself, like 2 times 2 and 1 times 1.
Right. I remember us doing some proof where we said that they were represented in like some way that we could test them, but maybe I could be misremembering that.
Oh, like you can write that in the form of 4k plus 1 or something. I don't exactly remember like the formula, but I believe it's one of your homework question.
It's in the book on page 102. Yeah, Greg just said it in the chat.
Yeah.
Okay, thank you.
All right, any other questions? Cool. So the next one is draw the Venn diagrams to verify the following properties of our set operations. So we wanted to use our Venn diagrams to prove the absorption properties. A intersects A union B is A. All right, so I will give you guys about 3 minutes to draw the Venn diagram. And remember, we just want to draw them step by step. So we start with the left-hand side, which in this case you should have three steps. Like the first box represent A, and the second one is A union B, and the third one is A intersects A union B. And we have the right-hand side, which is A. All right, so the Venn diagram for just set A itself should be pretty simple. You just kind of shadow the A set itself. And then what about A union B?
We just fill in
All
both
of it.
sides.
Yep.
Sorry to whoever I interrupted. My bad.
Yep, just fill all of the A and B. Just use another color. And then we just wanted the first one intersects the second one, which should still give you the same as the first one. All right, and that's your A intersects A union B. And similarly for the right-hand side, for the A itself, it's still going to be the set A itself, Okay, and then you can tell from the Venn diagram that your left-hand side is equal to right-hand side, and thus they are equal. All right, so the next one is the another Venn diagram problem. So we want to check if the following property is true. So we first just draw the Venn diagrams for both sides, and then if it's not true, just give a counterexample. All right, so let's start with the A minus B. What is the region you want? Oh, maybe I should just label each of them first. Okay. All right, so the A subtract B should be all the elements in set A, but subtract the part that intersects with B. So we should be this part. Okay, and similar for B subtract C. Should be all the elements in set B and besides the part and subtract the part where intersects with C. All right, and then we want the union of these two. Which should be everybody agree on this part?
Yeah.
Cool. And A subtract C, the right-hand side should be similar as A subtract B and B subtract C. We just exclude the part where it intersects with C. And are they equal? Or in other words, is the left-hand side a subset of the right-hand side?
No, because that would imply every element to the left is an element of A, or the right, and that's not true.
Mm-hmm. Yep, and in fact, it should be the other way around. The right-hand side should be a subset of the right-hand side should be a subset of the left-hand side. All right, but we need to draw out A, B, and C individually for this. No. So you only need to have separate them in as where you have like the three inside the parentheses. So just A minus B, B minus C, and the combination of these two. All right, so did anyone come up with a counterexample? Just give a specific number for A, B, C.
Oh, I came up with a counterexample, A, where the intersection between A and C is the empty set.
Okay, so what is your set A, B, and C in your case?
Oh, I only drew pictures. Sorry.
Okay, so like for a current example, you want like a specific like set for A, B, and C, like element in A, B, and C. Like you can say that suppose my set A contains element 1, and then my set B contains element 2, and C would be contain elements 3. And then you just check what is your A minus B in this case? What does that become to? Let me just move on to next, use the next page. So suppose you have set ABC like this as your counterexample. And what is A subtract B?
Just be the set 1.
Yep. It's like all the elements subtract the part where it intersects with B. Since like A and B has no intersections, that means just remain itself. So A subtract B will just be still be element 1. And then we want to also check that B subtracts C. And what is that?
Two.
Yep. The same reason for A subtract B. And then if you just take the union of these two, it should give us the set 1 and 2. So the set contains element 1 and 2. And this is our, I think, left-hand side. And then for the right-hand side, we have A subtract C, which in this case is just a set contains element 1 itself. And then clearly you can see that the set contains element 1 and 2 is not a subset of a set contain only element 1. And this is how you gonna give your counterexample. All right, any question on this part? Okay, so let's move on to the next one. We can do this one together. So we're given the universal set where 1, 2, 3, 4 all the way up to 10, and the sets A 2 contains elements 2, 4, and B contains element 1, 2, 8, and C 1, 2, 5, 6, 10. So we want to find the following: the power set of B intersects C. So why don't we just write out the B intersects C first? What are the elements in B intersects C?
One and two.
Yep, 1 and 2. And then we'll just want to write out the power set of 1 and 2. And what are they?
Would it be what the set 1, the set 2, and the set 1, 2?
Yep. But you're still missing one. What is another one?
Two, one.
So the set 2, 1 is actually the same as set 1, 2, right? Because the order doesn't matter in the set. If you have like set look like this, like the order pair, and then these two are not equivalent. There are two different sets. sets. But since you only
Would
have
it be
like,
the empty set?
yep, exactly, empty set. So empty set is an subset for all the power sets, no matter what you have for right here. You will always have an empty set. All right, so this would be your power set for B intersects C. And this is the notation you want to remember, like would you write a power set? It's like inside of the two curly braces, you have the 4 different sets. And separate them with a comma. All right, let's move on to the next one. So the next problem is still about set properties. Let's see. So just identify which of the following statements is true. So if you think it's a false statement, just provide a counterexample. And I don't need to have to prove like the true statement. I will give you guys about 1 or 2 minutes to work on the first one. Or to work on the first two, like part A and part B. Just think about if you can find a counterexample or not. If you can, then the statement has to be false. Otherwise, it's true. And for counterexamples, you always want to start with something like real simple, like just like containing like one element in the set. And just to see if that actually fails the statement. All right, so is part A true or false? So if that A is a subset of B, and then you just do A cross C is also a subset of B cross C, no matter what set C is. So this one actually is true. You cannot find a counterexample for part A. Because just think about A is always like a subset of B. And then you just use like the cross product to multiply another set, no matter what the set is. The A cross C will always be a subset of B cross C. All right, and what about part B? So if you think it is false, you can just start with some small example, like small counterexample. It would be hard if you just like staring at it to try to think about if it's true or not. If you can just write it out like what we did for the last example. I still set the A as a set contains only element 1. And then B is 2. Then the A union B would be just 1 and 2. And then the A subtract B would be just 1. And what about the A union B across A subtract B? What are the outcomes?
So wouldn't it be the ordered pairs 1 and 1 and 2 and 1?
Yep, exactly. And the order does matter here, so the A union B cross A subtract B is not the same as A subtract B cross A union B. All right, and then if we look at the right-hand side, we have A squared subtract B squared, where the A squared should just be element 1 squared, and that should give you the order pair 1, 1. And B should give you, B squared should give you the order pair 2, 2. And what about A squared subtract B squared?
It would just be 1, 1.
Mm-hmm. All right, and then you can see that this 2 are not equal. All right, any question on this, on part B? Okay, so actually similar steps for let's see. Similar steps for part C. This one is actually also false. So if you just set that as 1 and B as 2 and C as 3, you will still find out that these 2 are not equal. So that the commutative is not actually works in the Cartesian product. All right, so I'm just gonna stop here, and I can stay here for another 5 or 6 minutes. If you don't have a question, you're free to go.
Thanks.
Thank you.
Have a nice day.
Thank you.